rational equations. We are going to skip this word problem, and I'm going to just get right to the example with the graph, example 2. So here, a radical function, y equals f of x, is provided for you. And just by looking at that graph, we're going to interpret some of the information. So first of all, state the 0 of this function. State the x-intercept. Page 42. Okay, so where does this graph touch the x-axis? At -2. Awesome. If you see the word 0 and you see the word root, what do you think? What's it asking in this question, and what's it asking in this question? The exact same thing. It's asking for the x-intercept of this. Okay, so state the root when f of x is equal to 0. So when y is equal to 0, okay, that's pretty much what it's saying. When y is equal to 0, where's x? It's at -2. Okay, use the graph to determine to the nearest whole number the solution of the equation when, this is pretty much saying y equals 3. So what does x equal when y equals 3? Well, let's look. 1, 2, 3, and we go over and down, we're at 7. When y is at 3, x is at 7. Okay, next one, what is the root of the equation when we're at f of x minus 4 equals 0? First things first, I would probably rearrange this to f of x equals 4, so add the 4 to the right-hand side. And it's pretty much asking now, what does x equal when y is equal to 4? So let's go up to 4 and over. And I think in your book, when you actually look in person, it's at 14. Am I right?
Yeah.
Okay. Okay, so x equals 14 when y is equal to 4. These next examples are just a little bit trickier. They're saying when f of x plus 6 equals 0. So let's break this down first. If we had f of x equals 0, okay, we knew it was at -2, right? Okay, when f of x is 0, it equals -2. Let's go back to the transformations unit. What does this say when the function is moving which way? Left 6 spaces. So we have to take when f of x is at 0, and then we're going to move left 6 spaces. So when f of x is at 0, we're at -2. And then if we were to move left spaces, we would subtract 6 from that, so we get -8. So x equals -8 when we're at f of x plus 6 equals 0. The next one is saying when f of x is at 5, figure out that value, and then what would the transformation be? So right 3. So we'd figure out what is the value of x when y equals 5, and then we would move that value to the right 3 spaces. Or units. Okay, so line it up. When y equals 5, we are at, what does that go to? 23? You guys getting that? Okay, so x is at 23. And if we move to the right, that means we have to add 3. And so we get 26. And the last example is going right back to the functions unit. So we're going to be refreshing our memory on what some of these operations look like and what we can do with them. Okay, in this question, we're given 3 functions, f of x, g of x, and h of x. And we're going to determine graphically, I'll also show you algebraically, how to find the solutions to the nearest hundredth. So it's basically the intersection point or our x-intercepts. What does f divided by g of x actually mean? Functions unit. Perfect. So we have f of x divided by g of x. And to make life a little bit easier, I'm going to set that equation equal to 5 by adding 5 to both sides. And what was f of x? It was 2x minus 3. And g of x was x minus 1. That equals 5. So if you are asked to solve this graphically, I would set this side equal to y1, this side equal to y2, and you would find the intersection point. And you only need the x value because this equation only has an x in it. Okay, we don't care about the y. So let's just do that. So 2x minus 3 divided by x minus 1. Then we'll graph it. That's what that function looks like, but is that going to help me find the solution? No, I need to do y2 as well. Put in the 5. Okay, and we see that they're crossing each other right here, so we need to solve for that point. So second, trace, number 5. Move your cursor as close as you can. And press enter 3 times. Okay, so x will be at 0.6 repeated. If I were to put that as a fraction, you would get 2/3. Okay, so here x equals 2/3. And that's your solution. Now I don't know about you guys, but sometimes I personally find it easier to just solve it algebraically. So if I have 2x minus 3 over x minus 1 equals 5, I can take this x minus 1 and multiply it, cross multiply it to the right hand side, giving me 2x minus 3 equals 5 times x minus 1. Distribute the 5, and you get 2x minus 3 equals 5x minus 5, and we're going to solve for x now. Subtract 2x over gives me 3x. Add 5 over gives me positive 2, divide by 3, and I get 2/3. Okay, same as what we found on our calculator. So that's just a bit of review from Math 20, okay, how to solve a rational expression. Sorry, equation. You guys ready for the next one? Okay, what does this little circle mean? What do we call that symbol? Composition. We call this a composition. So the square root of f of x will be the composition of h of x into g of x. So we have g of h of x, which you guys said. That's good. Okay. But h of x is composed into g of x. So let's fill in what the functions are. F of x is 2x minus 3. And we have g of h of x, which was x plus 5. So if g of x is replaced with x plus 5, that means the x in g of x is also replaced with x plus 5. So we get x plus 5, and going back to g of x, minus 1, equals the square root of 2x minus 3. So we have the square root of 2x minus 3 equals x plus 4. So I'll show you guys in a sec how to do that algebraically, but let's just graph it. y1 will be the left-hand side, y2 will be the right-hand side. Get the square root 2x minus 3 Okay, this is a radical function. That's going to be equal to the linear function x plus 4. Based on that, do you think these graphs will ever touch each other? Okay, this one's varying slowly up like that. Okay, and this one has a consistent slope, which is much steeper. Are they ever going to cross? No. So because of that, and if you want, you can just draw a little picture. Okay, they're never going to cross. So if there's no intersection point, that means there's no solution. They don't cross. There's no value of x that we could plug in here so that left-hand side would equal right-hand side. It's just not possible. So just going back to math 20 again, let's solve this algebraically. We have 2x minus 3 equals x plus 4. How do I eliminate the square root? Square both sides, you got it. Okay, and just remember when you're squaring binomials, you have to fully FOIL. It's not just x squared plus 16. You gotta go binomial times binomial. Okay, so on the left-hand side, we're left with 2x minus 3. The right-hand side, we get x squared plus 8x plus 16. Should get a trinomial. Move everything over to the right-hand side, and we get 0 equals x squared plus 6x plus 19. And what you'll find is we can't factor this, so we have to use the quadratic formula. So let's do that. X equals negative b plus or minus the square root of b squared minus 4 times a times c. Okay, all over 2 times 1. So what's 4 times 9? 76? 4 times 19 is what I meant. 76? Pretty sure.
Yes.
So we have 36 minus 76. Are we going to end up with a negative value? Underneath the radical, are we allowed to have negative values? No, so it's a non-real answer, therefore no solution. Okay. Remember, you end up with a negative under the square root, which just won't work. So I'm going to leave it at that. We've pretty much covered this type of question over here. Sound good?